Devices Lab, IIT Mandi. This lab is coordinated by Dr. Vishwanath Balakrishnan. Our research mainly focuses on 2D materials like transition metal dichalcogenides, graphene and CNT, and some phase-changing materials like BO2. This is the main entrance of our lab. So before entering the lab, we have to take care that there should not be any contamination. So we have to take off our shoes and tie our hairs like this. So please come inside. The very first thing that you will see in our lab is fire extinguisher and the sanitizer. Safety is the most important thing in our lab. So whoever is entering, they have to make sure to sanitize their hands first and then proceed. This is our chemical room. So all the chemical reactions, that chemical synthesis, we do over here. So in this section we have all the safety things. For example, we have here lab coat. So we have to wear them. We have gloves here. Also we have mask and goggles and acid-resistant gloves and some PPE kits. We have some chemicals that need some low temperature to be maintained. We have this freezer. So inside, if you can see, we have kept photoresist. Yeah. So this is for their storage. Then next is our CVD room. This is the main room where all the magic happens. We have, in total, we have four furnaces. First one is vacuum furnace, and we have 2 single zone CVD and 1 3-zone CVD. So each CVDs we have dedicated for some particular group of materials. For example, here we do like MOS2, WS2 and RES2. This 3-zone CVD, this is dedicated to carbon nanotubes, this CNT, graphenes only. And this third single zone CVD we have kept for the oxides like BO2 and selenium and tellurium compounds. Other than these furnaces, we have 2 ovens. One is normal hot air oven and another one is a vacuum oven, and also we have one muffle furnace. As we are working in between these many gases, so we have to take care of our safety. So we have one gas sensor over here. So if there is any gas leakage, so it will produce sound and give us signal. And we have emergency doors for exit. We have emergency exit door here. So in case of fire or any other emergency, anybody working in this section can just run to backward. And backside to this room, we have one compressor room and cylinder room. So yeah, we have all the measures of safety. Safety is very important in our lab. Next to chemical and growth room, we have thin film deposition room, which is here. So we have 2 main instruments here, sputtering and ALD. So you can come here. This instrument is sputtering and Raju is here with us. So Raju, please.
Hi, this is Raju Nayak. So I am a PhD scholar. So this is the sputtering unit. Here we have 2 source sputtering, DC and RF. It is an automated system. Here we can do the coating of thin films, either metals, insulators, and same we can measure the thickness by using the QCM here. The minimum thickness that we can deposit by using the sputtering is in few nanometer, up to we can go up to 1 nanometer coating also we can do with this.
Thank you, Raju. So this temperature of Mandi is very cold. So we have multiple ACs and heaters in our lab to maintain the temperature. And here we have ALD system and Yadu Chandran. So hi Yadu, please explain this.
I am Yadu Chandran. Here we have ALD system. ALD is atomic layer deposition system. This is used for thin film deposition. Usually the precision of this instrument is in the order of nanometers. Here we use this for deposition of HFO2, AL2O3 and TaO2.
This is our characterization and measurement room. So the very first instrument kept here is optical microscope. So Bhumit is here, so I request Bhumit to explain this for us.
Hello guys, I am Bhumit. This is the optical microscope. This is the first instrument after preparing the sample on which we used to characterize the sample. This has several lenses like this 10x, 50x, 5x lens for different magnifications, and this has several modes like dark field microscopy and bright field microscopy, some polarization based techniques also.
Meet our senior most PhD student, Miss Divya Verma. So ma'am, what are you doing?
Thank you, Deepa, for introduction. Hello, I am Divya. I am working on nano indentation. So you can see this is the nano indentation instrument. Here we can do is study of mechanical properties of different materials. We can use various materials like metals, polymers. Even we can use ceramics. We can also use bulk and thin films. We have three different stages. We can do room temperature indentation as well as we can do high temperature indentation. For high temperature indentation, we can go up to 650 degrees centigrade. Since we can go up to 800, but the working temperature is 650 degrees centigrade. We also have ECR stage where we can do the contact resistance with respect to the deformation or load. We can study the material's resistance for like piezoelectric materials. So we have different, we can use different kind of materials here. Now we are using the oxide materials, and we can also do thin films monolayer materials mechanical properties. The higher the load we can go.
Now next to nano indentation, we have electrochemical workstation, and Nitika is doing her experiment.
Electrochemistry measurements. So this is our electrochemical workstation. We have procured from Biologic. This is a VSP system, and here we are doing some electrochemical measurements with 3 electrode system. So this is our setup, and we also work with 2 electrode system for various energy conversion and energy storage applications. Our prime focus is mainly on the supercapacitor of 2D materials and their hybrid with carbon-based 1D nanostructure.
Materials are very well known for its electrical and optoelectrical performance. So for these kind of application, we have this 3-terminal electrical probe station to measure its electrical and optoelectronic properties. In this system, we place sample here and apply a voltage from key side source meter and do the measurement. We also have a temperature stage for heating experiments, and we can measure temperature dependent current voltage characteristic, and we have 3 lasers, red, blue and green. So we can see the effect of light and do optoelectronic testing, and all these things we can measure in this system. Other than this, we have also some being developed instruments like this gas sensing chamber. Soon it will be ready and available for use. So this was all about our lab.